The last thing with chain rule, specifically algebraic chain rule, I keep saying that because I want to make sure we kind of separate that from the trig ones that we'll do, is what do we do when we have what I call combination problems? And so what I mean by combination problems are when you have to use multiple rules and not your multiple basic ones, but looking at multiple more higher level rules in one problem. So your most common combinations are going to be doing a product rule and a chain rule together, or a quotient rule and a chain rule together. And Delta Math actually has you doing a little bit of both of that. So I want you to see a little bit just to kind of get an idea of what to do, and also to give you an idea of how much you need to simplify. I don't want you to spend tons of time doing extra algebra when you can get the derivative and kind of have enough be enough. So this first one is y equals 4x squared times the quantity 3x plus 4 being taken to the fourth. And when we look at it and we start thinking about rules, well, what you'll notice is we have two things being multiplied together. So we are multiplying here. And then we also have a composite function with an extra power there. So this is going to be a product rule and a chain rule combined. So I'll just kind of put a little PR and a CR there. So we start our derivative with the product rule. So first times the derivative of the second. The derivative of the second is going to be where the chain rule comes in. So power out front, take the original to a power 1 less, and then take the derivative of what's inside. And then plus the second times the derivative of the first. So the second is 3x plus 4 to the fourth, and the derivative of the first is 8x. So here when we talk about simplifying, there are some little things that you may do. I don't want you to do a ton of extra algebra. So you could multiply all the coefficients together. So you could do 4 times 4 times 3, which is 48, and then the x squared, and then have the 3x plus 4 to the third. I usually put the 8x in front of the 3x plus 4. And while there are things you could do further, truly, as long as you have the derivative correct and you have all the parts of the different rules, you don't need to do a lot of extra algebra to finish these. The second one is a quotient rule and a chain rule being combined. That numerator is x to the third. I feel like that 3 is kind of faint. So you've got a quotient rule because you have a numerator and denominator, and then you also have a chain rule because in the bottom you have a quantity being taken to the fourth power. So we're going to start with our quotient rule. So bottom times the derivative of the top. Derivative of the top is 3x squared. My x doesn't want to write there, minus the top times the derivative of the bottom. Here's your chain rule. So power out front, power 1 less, derivative of what's inside. I feel like I'm running out of room there. And then all over the bottom squared. When I square something that's already to the fourth, it will be to the eighth. I'm going to clean it up again a little bit, plus I feel like I was cramming space. So I'm going to put the 3x squared in front of the 4x plus 1 to the fourth. And then I'm also going to bring this 4 and this 4 to the front. So I have 16x to the third, and then a 4x plus 1 to the third, all over 4x plus 1 to the eighth. Now, as far as simplifying, one thing you may see done is every single term in this fraction, both terms in the top and the term in the bottom, have at least a 4x plus 1 to the third. So you could reduce that. You could take everything down by a factor of 4x plus 1 to the third. So that would only leave one 4x plus 1 there. That would leave none of them here, so just the minus 16x cubed, and then a 4x plus 1 to the fifth. I do think that on Delta Math, it does say answer in any form. So it gives you a little bit of a freedom of how much you want to simplify. So again, don't overdo it with the algebra because sometimes you just end up working yourself into a mistake. Two more for you. So my next one, I want to show this one right after the one we just did, because what's happening here is we still have a quotient rule and we still have a chain rule. So it's actually the same combination of two rules that the last one was. Quotient rule because you have a numerator and denominator, and chain rule because you have an entire function to the second power. Here's what makes this one different. What makes it different is the order in which we use those two rules is actually flip-flopped. So it actually starts with a chain rule, whereas, let me go back to this previous one, the first step in this one was we did the quotient rule first, and then within the quotient rule, we had a chain rule. Well, this one's the opposite. This one, you actually start with a chain rule, and within the chain rule, you have a quotient rule. So I've got power out front, power 1 less. So all of this is going to be dropped down to a first power. You don't even need to write the 1. And then the derivative of what's inside, that's my quotient rule. So that's going to be bottom going to have lots of parentheses going on here, times the derivative of the top minus the top times the derivative of the bottom, all over the bottom being squared. And again, how much simplifying you do is up to you. I usually, especially on Delta Math, look at the directions. And again, if it says in any form, kind of go with it. If it does ask for a simplified version, the one thing you may see simplified, and this is often true with a quotient rule, is you may see this numerator simplified. So like distributing, combining like terms. You're not going to see much with this denominator simplified at all. You could combine these denominators since they're both x squared plus 3. You could put them together and say there's actually 3 of them there. But that is, it's totally up to you how much simplifying you want to do. And then finally, the last one, I wanted to finish with this one because this one you do not need to do combination of rules, because if you simply rewrite it with a negative exponent, you can do a chain rule and avoid a quotient rule. So I want to show you one of the easy ones because sometimes we get caught up in these complicated ones. So power out front, power 1 less, we'll drop it to the -3, derivative of what's inside. And all I ask is that you don't leave negative exponents. So your final answer is going to be 28x, and then you're going to move the x squared plus 4 to the bottom, being cubed. And that's an example of one where quotient rule is not necessary because rewriting makes it easier. So those are your combination problems, and they will help you derive when you're looking at multiple rules.